6 and welcome to today's lesson, science lesson about conductors and insulators and electricity. In this lesson, we're going to be seeing and learning about light bulbs and what makes them light up. And we are also going to be seeing conductors such as this metal spoon and objects such as these that are insulators and don't conduct electricity. Right, so let's get started with the lesson. I'm going to share my screen. This unit we're learning about circuits and electricity, and in this lesson we're learning about conductors and insulators. Okay, let's start off with a quiz to refresh our memory from what we learned last week, all about static electricity and atoms. So please get a pen and paper out and write down your answers. Question number 1. What is smaller, a cell or an atom? What is smaller, a cell or an atom? Pause this video now and write down your answer. Question number 2. What is at the center of an atom? What is in the middle of an atom? Pause this video now and write down your answer. Question 3. What orbits the center of the atom? What orbits the center of the atom? So another way of saying that is what spins around the center of the atom? Question 4. Where is a common place people get static shocks? So a little clue is that it might happen when you touch a metal doorknob. Question 5. When you rub a balloon, it becomes positively or negatively charged? When you rub a balloon, it becomes positively or negatively charged? Please write down all your answers before going on to the next page. Pause this video now. Okay, I would like you to mark your answers using a different coloured pen if possible. And we want to use integrity and honesty when marking our answers. Question 1. What is smaller, a cell or an atom? The answer is an atom. Here's a picture of an atom. It is the smallest thing in the world, and it is much smaller than cells. What is at the center of an atom? The nucleus is at the center of an atom. We see here in the middle, the nucleus is in the middle. Question 3. What orbits the center of the atom? So what spins around the center of the atom? We know that electrons spin around the center of the atom. And extra points for the person who can tell me what charge the electrons have. They are negatively charged. Question 4. Where is a common place people get static shocks? Their fingers or hands when they touch doorknobs, but there might be a few other answers. And question 5, when you rub a balloon, it becomes negatively charged. Different materials in the world get different charges when you rub them, but we can see here that the balloon becomes negatively charged, and we can see that the hair sticks to it because the hair is positively charged. And you might have heard the phrase, opposites attract. Well, that's because opposite charges attract each other, and that's why your hair stuck to the balloon. Okay, let's get started with the new content for today. How do different materials interact with electricity? We know that some materials conduct electricity really well, conductors, and some materials that don't, insulators, such as this pineapple. Okay, let's have a look at some different materials. Insulators do not allow electricity to pass through them. So here are some examples of insulators: rubber, glass, oil, diamonds, and dry wood. And let's look at some examples of conductors that do allow electricity to pass through them very easily. Silver spoons, gold, copper, steel, and seawater. I wonder why seawater, as opposed to other water, conducts electricity really well. Can anyone think of why? It's because of the salt in seawater. Salt conducts electricity. Let's have a look at insulators and conductors in a bit more detail. A conductor is a material that allows charges to flow easily throughout the material. Most metals are conductors. An insulator is a material that does not allow charges to flow easily throughout the material. So glass, as we saw, rubber, silk, and plastic are examples of insulators. I would like you to have a look at this picture here. We have wires with plastic coating. Why do we think wires have plastic coating? If you look around you right now, you will probably be able to find a wire, probably coming out of your computer, that has a plastic coating. It's because the plastic is an insulator and the metal is a conductor. If you didn't have the plastic coating it, you'd get an electric shock every time you touch the wire. So we see and use insulators and conductors in everyday life. Okay, let's look at electrical circuits. A circuit needs to be complete in order for electricity to flow. So the light bulbs that are on in the room you're in right now are closed circuits because they have electricity flowing through them, and that's why the light bulbs are able to shine. If there is a gap in the circuit, the bulb won't light up and electricity won't flow. Please, could you put your finger on the gap in this circuit now? Yes, it's right here. So that's why this light bulb is not shining, because this circuit is not complete. Here we have a simple circuit switch. What would happen if one of the clips was removed? Think about it for a moment. If one of these clips was removed, the circuit would be broken, and what would happen to the light? It would no longer shine, because we need a complete circuit in order for electricity to flow. We know that conductors allow electricity to pass through them. So when used in a simple circuit, the bulb will light up. Insulators do not allow electricity to pass through them. So when used in a simple circuit, the bulb will remain off. Let's refresh our memory on electrons. Materials are conductors because they have free electrons. They conduct the electron current very easily. Extra question, what charge do electrons have, positive or negative? Negative. Next question for you. Here's a simple circuit. Would this light up? Do we think that this light bulb would light up? No, the answer is no, because this banana is an insulator. It does not conduct electricity. So it's the equivalent of having a gap in your circuit. Okay, we have two different types of bread dough here. We have one with sugar and one with salt. What is the difference when they are placed in the circuit, and why would this be? Remember what I told you earlier about salt being a conductor. Do we think that if we place this where the banana previously was, it would conduct? Well, the answer is yes, because salt is a conductor. However, if we put sugar in the simple circuit, it would not conduct electricity, and therefore the light bulb would not shine. Why are insulators so important? Well, let's just look at these pans. Can you please put your finger on the screen to where you see an insulator? There, there, and there. And that's because if we didn't have these plastic insulators there, we would burn our hands every time we touch the metal, because the heat would conduct through the metal, and if we didn't have an insulator, it would get conducted to our hands. So that's why we have them on the handles and on the lids. How many items do you use that require electricity? Just looking around you right now, the computer you're using, the hair dryers, you use electricity every day and it's a crucial part of our lives. A note on electrical safety. Hopefully this image also makes you feel really uncomfortable. As I said, water can be a conductor, and putting this baby that in their mouth is very dangerous because it could give them an electrical shock and could be extremely dangerous. Let's look at this man trying to get his toast out of the toaster with a fork. Remember what I said about forks and spoons and metal being conductors? The electricity could conduct through the toaster, through the fork, and give this man an electrical shock. So it's not smart to do that. Please don't ever do that. It's very dangerous. Right, I would like you to complete this independent task, either by printing out this sheet or just copying it in your book. Either is perfectly fine. Please fill in the gaps here and give us some examples of conductors and insulators. I've given you a few clues here. See whether you can find different ones. Right, everybody, I hope you've enjoyed today's science lesson, and I'm really looking forward to seeing everyone's work uploaded onto Seesaw. Have a great day.